with the properties when we're dealing more with variables and less with just plain numbers, and make sure that we are okay with all of those pieces. So, if I asked you to work this problem and to separate those logs, what would we need to do? Add, right? You have things being multiplied, you do the log of each one, add it together. You have to write the log base A. If you don't put the base, I will take off. So it's log base A of x plus log base A. I'm going to rewrite this as x squared plus 1 to what power? 1/2. Okay. Then, what's the next thing we could do? Exponents drop down in front. Okay. Can I break up things that are added? No. We can separate multiplication and division, not addition and subtraction. Can I bring this square down in front? No, because it's not the whole thing that's squared. It's just one. So this is my final answer. Okay. Let's look at this one. So, how many logs am I going to write when I write this? 3, won't I? On the top, I have two things multiplied, so each one gets a log. This one, I didn't have a base written on my log, so I'm just going to keep it that way. So it's log of x plus log of x plus 2. This is divided, so we subtract the log of x plus 3 squared. Remember, anything on the bottom gets subtracted. If there were multiple terms on the bottom, we would subtract both of them. Okay, now what can you do? Drop the 2 down. Can I just erase it and move it down? Can I separate any more? No? Can't break apart the addition, so that's my final answer. I'm going to put some up here for you. I want you guys to do those 2. So the first one, if you just broke it up, just log base A of the top. A square root is like a power of 1/2, so I can just drop that down in front. Now, I have two things on the bottom, so what you have to make sure you're doing is subtracting both of them. So it's minus log base A of x to the third, so you can drop your cube down in front. This term is also on the bottom, so minus log base A of x plus 1 to the 4th, so the 4 comes down in front. Yes?
Why don't you add those two?
So technically, you would, but if you think about it, you do the top minus the bottom, and that's an addition. So then if you run that negative through, it turns that into a minus. Other questions? D. 3 comes down, so 3 log base 2 of x minus log base 2 of x minus 3. Just make sure you are putting parentheses around it if it's multiple terms, just so we realize that the log applies to both parts of it. All right, so we're okay with the expanding. Let's go the other direction. So I'm going to give you one that's broken down and we're going to put it back together. Right. I looked at this one. I only want to write the log base 4 one time. So the x is a positive, so it's got to go on top. Minus, so that has to be divided by y. Now be really careful. Plus log base 4 of z. So where does the z go? Top or bottom? Top. Anything positive goes on the top. Anything negative goes on the bottom. So just don't be fooled because of the order I wrote the problem in. Pay attention to the signs. If I look at this one. So I would have log base b. 4 would go up, so it's an r to the 4th. It was positive, so that's on the top. Minus, so that'll be on the bottom, the s to the 5th. What if this had been a negative 4? They would both be on the bottom, so what would I put on top? A 1. Okay. Let's do a little more challenging one. Give you a second to write that down before I talk about it. So if I start condensing this, we have a log base a. This is a positive, so it'll go on top. The 1/3 is the exponent, so it's an x to the 1/3. Plus, so still on top, 2/3 would turn into the exponent, so y to the 2/3. Minus, so on the bottom, xy. Is that okay for a final answer? No, we can simplify that. What's the exponent rule when you have things on top and bottom? Subtract. So, do I have more x's on the top or the bottom? The top is a 1/3, the bottom is a 1. 1 is bigger, isn't it? So it's going to end on the bottom. 1 minus 1/3 is 2/3. The y's, I have a y to the 2/3 on top and y to the 1st on the bottom, so it'll go down to the bottom. 1 minus 2/3 is 1/3. So if everything's gone from the top, you just put a 1 as a placeholder there. Let me give you guys a few. Sure. It's me.
Why didn't we write it as like the cube root?
You could. Are you at? If you did that, that would be like the cube root of x squared. So really, this is what happens if you get the cube root off the bottom. This, so technically it depends on which rule you want to follow. If you wanted to get the radicals off the bottom, that would be your final answer. Here, I just want you to put them together as concise as you can, so I'm not worried about radicals on the bottom in this scenario. Other questions? So here's a couple for you. First one, condensed, you have a log base A. All three of these are adding, so they will be multiplied together. So it'll give us a 9x times x squared plus 1 on the top, minus, so divided by the 5. You could distribute out the top if you wanted 9x cubed plus 9x, that's fine, either way. Works for your answer. E, we're going to have to be a little more careful here. A square root is like an x to the 1/2. With that 3, you would have to bring it up. So what power does that turn into? 3/2. You would have to multiply those. Okay, this would be minus log base 3 of x cubed to the 4th. So that's x to the 12th. So then the subtraction turns into division. You write the log base 3 one time out in front. You have x to the 3/2 over x to the 12th. What do we do with those exponents? Subtract. We have more on the top or bottom? Bottom. So you get 1 over x to the 21/2. Did I get you with having to multiply your exponents? Do we need more problems like that? One last type of problem I want to talk about. There is a section on the homework that's going to give you some values of logs in the directions, and then ask you to simplify some things. So it's asking you to essentially use your properties to break those down. So I'm going to give you a sample problem here so we can talk about that. We're going to skip that. We're going to go to this. So assume that log base 10 of 7 is 0.8451. I want to use that to find each of the following. So that means you can't just write down final answer. You have to show me your work so I know how you got there. Since I only gave you log base 10 of 7, I have to figure out how to rewrite this using the 7. So how would I write that? 7 squared. And then we know properties of logs. The exponent would come down in front, so it's 2 times the log base 10 of 7. But then we know log base 10 of 7 is this decimal. So now I can plug that in. So that would give me 1.6902. How would I rewrite B? Now properties of logs, we can split that up. Log of the first plus log of the second. Log base 10 of 7. I told you what that equaled. What's log base 10 of 10? 1. Saying 10 to what power equals 10, so that's just a 1. So we get our answer. So on these problems, all I'm wanting you to do is manipulate the log to get to the point where you can plug in the decimal ID. Any questions there? Okay, I want to do some review for the quiz, if that's okay with everybody. Section 4.1 was when we talked about inverses. So what types of functions had inverses? 1-to-1. The y couldn't repeat for it to have an inverse. Let's say I gave you I'm going to give you a few minutes to try and see what you remember. I want you to find the inverse. And I want domain and range of both the function and the inverse. So take a few minutes and see if you remember what to do. Change f of x to a y, and then switch x and y. So every y becomes an x and every x becomes a y. So we now have 2 y's in our problem. We have to solve for y. So most of you just multiply by your denominator. Those drop. Over here you have to distribute. So we have xy minus x equals y plus 2. I am solving for y. Oops, I didn't mean to highlight that one. And I have 2 y's in my problem. So what do I need to do? Get them on the same side. So I'm going to subtract over this y, add over that x. Then what would we do? Can't do that yet. 2 terms, what do they both have in them? You have to pull out that y. When you do, you're left with x minus 1. So we have y equals x plus 2 over x minus 1. And then final step for the inverse, I want you to write f inverse of x. Now, this doesn't happen very often, but what happened here is the same as my original one. That only happens if the original function is symmetric across the line, y equals x. So that's just kind of a fluke thing. It does not happen very often, but it does on occasion. Okay, we struggled with that one a bit. Can I do another one and do the domain and range of it? Because it'll be a little more interesting than this one where everything's going to turn out to be the same. Okay. Let's say I gave you this one. So walk me through the steps. How do I find the inverse? And then so we usually got rid of the fraction, so multiply by y plus 4. So that gives me an xy plus 4x equals -3. You could pull out the x, but we actually don't have to, because what am I trying to solve for? Y, and I only have one of them here. So just to get the y by itself, I could just subtract over my 4x and then divide by x. So then, final step, you change your f or your y to f inverse of x. So we have -3 minus 4x over x. Let's do the domain and range of these. Make sure you're labeling what's the function, what's the inverse. Don't just put dr. Tell me which is which. The domain of the original function. We know if it's a fraction, what's true? Bottom can't be 0, so this domain would be -infinity to -4 union. And we know the domain of the function is always equal to the range of the inverse, so I automatically get to write down my range. Okay, let's look at the inverse. What's the domain of that? What's the one thing x can't be? 0. So the domain of the inverse would be -infinity to 0, union 0 to infinity. And that would be the same as the range of the original function. Is that one all right? One more thing I want to mention from section 4.1. If I asked you if two functions were inverses. There's a couple ways we could do this. Give me one option. Right, you plug them into each other, and what should you get out? X, every time. So, we would do F composed with G, and G composed with F. If either one does not give us an X back, then they're not inverses. So F of 1/3 x minus 3. Plug that into F, so 3 times 1/3 x minus 3 plus 9. So I get x minus 9 plus 9, which is x. If one of them equals x, is that enough? No. We do have to check the other way. So that gives me an x plus 3 minus 3, which is x. So yes, these are inverses. What if you forgot that method? Is there another way you could figure out if they were inverses? How? Yeah. Pick one of the equations, find the inverse, see if you get the second one for your answer. That would also work. Okay, that's section 4.1. Section 4.2, we talked about the exponentials. So I might ask you to graph like y equals 4 to the x power and y equals -4 to the x. Okay, we graph exponentials how? What do we have to do? T-chart. What points do we plug in? 4 to the -1, 4 to the 0, and 4 to the first. So I've got -1, 1, 4, 0, 1, 1, 4. The graph looked something like this. If I have that, how could I graph B? Transformations. And negative out in front is like saying I'm going to make all the y's negative, so it flips it over the x. So graphing exponentials and transformations of those. Just remember 3 points for your original and then transformations. Then we solved exponential equations. We've done a lot of that. I'm only going to do maybe 1 or 2 as a refresher. If I said 1/3 to the negative x minus 4 equals 27 to the x minus 6, how would I solve that? What do you want to use for your common base? 3. So 1/3 is like 3 to the and 27 is 3 to the 3rd. So multiply those, so that gives me an x plus 4 and a 3x minus 18. Once you get to this point, what do we do? So if I subtract my x, that's a 2x, add my 18, that's 22, divide and you get 11. Okay, let's do one more. Let's say I gave you e times e cubed to the x minus 1 power equals 1. Do a hard one. Okay, what's my common base? E. So this, and e by itself is like what power? This would be e to the 3x minus 3. How would you write 1 as e? If these are multiplied, what do you do with the exponents? Add them. So 1 plus 3x minus 3 would be 3x minus 2. Bless you. I'm going to get 2/3 first. So are we good with the inverses and exponentials? Section 4.3 was the log stuff. So I won't do as much with that. We've been working on it. The stuff like we did today, the expanding and condensing. I'm not going to do any practice problems on it. You've got homework, but those will be on there. Graphing logs. If I said to graph y equals log base 4 of x. How do you do that? Change it to exponential, so it'd be 4 to the y power equals x. Make your t-chart. This time we're going to plug in for the y because it's the exponent, so that's our -1, 0, and 1. 4 to the -1 is 4, 4 to the 0 is 1. Sorry, 4 to the -1 is 1/4. 4 to the 0 is 1, and 4 to the first is 4. So we get 1/4, -1, 1, 0, 4. Remember, these always have a vertical asymptote. And could you guys do transformations to graph these as well? So I probably won't do any more graphing ones. And then I may just do 1 or 2 log examples, and then we're done. So if I said log base x, 125 over 216 equals -3. Alright, what would you do to solve this? Exponential. So it'd be x to the negative 3 power equals 125 over 216. How could you get rid of the negative? You could take each side to the negative 1 power. So that'd be x to the positive 3 equals 216 over 125. Then to get rid of the cube root. Cube root of 216 is what? And cube root of 125? So we get 6 over 5. Remember on these, the base and the argument both have to be positive. The only thing that can be negative is what it's equal to. Last problem. What would I do here? Exponential. So 3 to the x equals the cube root of 256. Have to get a common base. A cube root is like a 1/3 power. I need to change this problem. 256 is not a power. It's not going to come out very nice. Let's just make it a log base 4. That'll work out. Okay. 256 is 4 to the 3rd. Sorry, not 3rd, 4th. I keep wanting to write 3s apparently. So then we have 4 to the x equals 4 to the 4/3. And so x is 4/3. Okay, so we've done a lot of review right here over everything. Do you guys feel confident about the type of stuff that'll be on your quiz? Okay. So we are done. Is that the right? No, that's not the one I want to give you. We are going to do got a little time right now to work.